Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azfar bin Yeop Kamal. I'll be presenting my final year project 2 on the topic of bridge analysis of an embankment of dam. First, I'll be going through our presentation outline. So firstly, we have 4 main topics: introduction, methodology, results, and discussion, and then conclusion and recommendation. So first, introduction, I'll be presenting to you on the flood in Malaysia, Heck-RAS and also regression equation. Next, methodology, I'll be presenting to you the study area of the study, and then next, our estimated bridge parameter, and lastly, the model setup for the study. Now we'll be moving on to the result and discussion. We'll be discussing on the bridge peak flow and elevation, and then also our inundation map resulted from the simulation. And then lastly, we'll be having our conclusion and recommendation. Introduction. Flood in Malaysia. Malaysia is known for its abundance of rainfall, which amounting up to 2,000 to 4,000 millimeter of rainfall per year. This is mostly due to the heavy rainfall during monsoon season, which usually flooded the areas nearby river. Traditionally, the occurrence of extreme flood occurred every 3 years, which also resulted in the loss of life and property in the populated downstream areas. In Malaysia, there are many embankment dams constructed across the country to encounter this issue, or we can say to do a flood control. However, due to the massive potential energy storage, there is always a possibility of a dam breach. Thus, this paper aims to study on the bridge model of Hydrologic Engineering Center River Analysis System, Heck-RAS, and then to study and then to discuss critically on the regression equation and the bridge model of Heck-RAS. And lastly, to analyze the breach of an embankment dam through available dam data. Moving on, Heck-RAS. Heck-RAS is an abbreviation of Hydrologic Engineering Center River Analysis System, Heck-RAS. So, for your information, there are lots of hydrodynamic models used in the institution for a dam breach study, such as Heck-RAS, HMS, NWS flood wave, or NWS Yeop model. So for this study, we will be using Heck-RAS for our bridge model, and we will be using an input data from digital elevation model, or DEM in short, and then we will be using the estimated bridge parameter gain from the regression equation. So next, regression equation. For this study, we will be focusing on 3 main regression equations, which are Froelich 1995A, and then Froelich 2008, and lastly Von Thun and Gillette 1990. So these 3 regression equations will be used to find and to calculate the bridge dimension, which are the bridge width, and then the bridge formation time, and also the bottom bridge width, and lastly the bridge side slope. So all 4 of these bridge dimension will be used in the input of our bridge plan data in the Heck-RAS simulation flood. As you can see on the bottom of this slide, this is the summarized table for our bridge dimension obtained from the regression equation. Second topic, methodology, study area. Our study area is Repas Baru Dam, located at Sungai Repas in Pahang State. Repas Baru Dam is considered a large dam and had a significant hazard classification by the Department of Irrigation and Drainage, or Jabatan Pengairan dan Saliran. Commissioned in 1963, Repas Baru Dam is located 610 meter downstream of Old Repas Dam and act as a silt retention. as you can see in the slide on the left side, this is the general details of Lepas Baru Dam, which we will use this detail to calculate the bridge dimension for our input in the bridge plan data. Moving on to the estimated bridge perimeter, as you can see in the slide, there are 4 bridge plan data. First is from Frolic 1995A, secondly is from Frolic 2008, thirdly is from Vontun and Gillette for erosion resistant, and lastly from Vontun and Gillette for easily eroded. There are 2 distinct characteristics of the bridge perimeter. Firstly, for Frolic regression equation, both of them have a steeper side slope compared to Vontun and Gillette. As for Frolic 1995A has a bridge side slope of 1.4, while Frolic 2008 has a bridge side slope of 1.0, while both of Vontun and Gillette had a side slope of 0.5. The next distinct characteristic is that Vontun and Gillette regression equation had a wider bottom bridge width compared to Frolic regression equation. Model setup. So first we will extract DEM data from our data collection, and we will portray the data in our HECRAS by using RASMapper. As you can see in the right slide, in the right part of our slide, we have the 2D satellite image of our study area, and below it is the 2D geometry model of our study area. Next, we will draw a 2D flow area polygon for our reservoir and our surface area, or we call it as a downstream area that will be affected by the flood. Then we put the input boundary condition and define the dam structure and bridge data plan, and lastly we will do the simulation according to the bridge data plan. Next, result and discussion. The bridge flow for an overtopping failure, as you can see in the graph, the peak discharge for an overtopping failure is between 1637 cubic meter per second and 1686 cubic meter per second. It is found out that for Vontun and Gillette, for both situations, easily eroded and erosion resistant, that the peak discharge is the same. It also determined that Frolic 1995 and Frolic 2008 has a different peak flow discharge of 85 cubic meter per second. The maximum peak discharge is recorded around 5 hours into the simulation. Elevation. So the max elevation for an overtopping failure at Lepas Baru Dam is around 127 meters for all regression equation. However, if you can see from the graph of elevation, there is quite significant difference between regression equation of Frolic and Vontun and Gillette. As you can see before, from the bridge flow, we have approximately the same value, not far from each other for the bridge flow. However, in the elevation is not the same. For Vontun, as you can see in the first 30 minutes, for Vontun and Gillette for erosion resistant, it has the highest elevation of 21.57 meter, while for Vontun and Gillette for easily eroded had a lower elevation of 120.68 meter. Meanwhile, for both Frolic 1995 and 2008 had around the same elevation of 119 meter in the same period of time of 30 minutes. So the time for maximum elevation is the same, 300 minutes or 5 hours into the simulation. Inundation map, as you can see in the table, in the slide, this table is the summary of our dam bridge simulation. So there are 3 main critical locations. First is SMK Kuala Lepas, Taman Bukit Chamang Residential Area, and 25th RMD Base Camp. So from our dam bridge simulation, it is found out that the flood wave will hit SMK Kuala Lumpur and 25th RMB base camp around the same time, which is 4.5 hours after the breach, as they are located close to each other. And as for the Taman Bukit Chamang residential area, the flood wave is expected to hit around 30 minutes after the initial flood wave. So as you can see on the bottom part, there are three images. So the first image on the left part, the light blue part, is the image for the depth of our simulation, and in the middle is for the velocity that we hit the downstream area, and then lastly on the right side is the water surface elevation for the downstream area upon the dam breach simulation. Finally, conclusion and recommendation. Conclusion: evacuation plans for SMK Kuala Lumpur and 25th RMD base camp should be prioritized first, as they had a shorter response time compared to residents in Taman Bukit Chamang. However, resident in Taman Bukit Chamang is exposed to the danger of a probable maximum velocity flood wave of 1.26 meter per second, as flood debris may be swept away to their area and endanger the resident life. Government and local bodies are required to have an accurate forecasting inundation level and arrival time of flood wave in order to build a reliable or adequate emergency response and action, as to reduce or minimize the damage from a dam breach. Recommendation: it is recommended that the collection of input data parameter and site location can be improved further. As in this study, the actual size and shape of the reservoir and dam are not available. As I looked through in the Raspmapper and the Google Pro, the image is not clear. It will be very helpful if in the future, if the user can obtain the data for the how large the reservoir and how is the shape of the reservoir and dam, it may have a better simulation result than in the study. Okay, so I think that's all from me. Thank you. Assalamualaikum.